Hello, so today we are going to do this problem, which is part of Leetcode November daily challenge. Insert, delete, get random in O of 1. So what the problem says is we have this class randomized set, and we initialize it, and we want to insert a value into the set if the value is not already in it. And we want to return true if it was not present and we were able to insert it. Otherwise, we want to return false. The second operation is remove a value, where we want to remove a value if it's present. So we want to return true if the item was present and false otherwise. So you can think of it as basically returning true if the operation was successful. Yeah. And we have GetRandom, where we want to return a random element from the current list of elements. Basically it's guaranteed that at least there is one element in the list when GetRandom is called, so we don't need to check for empty. And we need to have the same probability of each element being returned, right? And then here they say that we have to have all these functions be on average of 1 time, right? Yeah, I don't think we need to go into the examples. It's pretty straightforward. The calls are 2 to the power of 5, so yeah, O of 1 would be useful. First, let's just solve it in a simple way that is not O of 1, maybe O of 1 and for at least maybe remove, and then from there we can solve it in O of 1 time. Okay, so the first thing we need to do is pretty simple. We can just add them to the list, insert them at the end of the list, and then just remove the value in Python from a list. That would be an O of 1 operation, right? So we would have a list of values, and then here we will want to insert it at the end. Okay, and then here we want to remove self dot. Sorry, there is only so here we want to remove the value. We will later do the returning true or false, right? And then here we want to get the random. How do we do that? Well, we can just use Python has random package that has a random integer, right, between 2 values. So what do we want? We want to get a random index from the list, so from 0 to the length of self-dot values, but we want only valid indices, so -1. This one is inclusive because rand int, the values, the range it takes is inclusive. So we get the index and then we just return that value. Okay. Now let's do what the problem asks us to do in terms of returning true. So we want to return true if the item was not present and we were able to insert it. So we want to check if the item is not present, so not, then we want to insert it, and then we want to return true. Okay, but otherwise if it wasn't present we just return false, and here we want to remove it only if it's present, and we want to return true if it's present. So if val is in self.values, here we want to return true, and we want to return false. By the way, this is also like this check here contains is O of n, so we will need to optimize that here. Okay, so all of these the 2 operations here are O of n, this is O of 1, so we want to move this to be O of 1 instead of O of n. So let's first run it, make sure it passes, and then we can optimize here. Yeah, it's, oh okay, so yeah, sorry, it's values that remove, and submit. Okay, so that passes. Now let's optimize. So what we can do is actually just have a dictionary for positions. This is basically so we can both find if it exists. If a value is in the array, it would have a position in the positions map. And then the other thing is also to optimize this remove here. How will we optimize this remove? So what we can do actually is pretty simple. So we have a list of elements. Let's say we already added maybe 5, 7, 2. Doesn't have to be ordered, right? And then we have the positions for each. So we have our positions array that has like 1 at 0, 5 at 1, 7 at 2, and then 2 at 3. Okay, so what we'll do, let's say we get remove for maybe remove for 5. Okay, so how can we do this in an optimal way? So in the what operations do we have that are O of 1? So for a list in Python, popping the last element is O of 1. Right, so what we can do is pop this 2, put it in 5 place, and that would be it. And we will need to change this to be to point to 1, and we will remove this, right? So that would be O of 1 operations, except the delete for dictionary, we'll need to find a clever way to not make it O of n. Okay, so how would we do that? So first, the part that we know is that we will just we'll get the index we'll get the index for the last position, right? So so first we will just get the index for self.positions for the value that we are going to remove. So we get the index for 5. Okay, so that would be, in this case, for 5 it's 1, and we'll put the 2, we'll save it in that position, right? Because we'll remove 2. So this would be equal to self.values at position either the last position, right? In Python we can do -1 like this. And once we do this, our list will be like this. It would have 2 here. And then we can just pop this 2 because we put it here. So self.values.pop. And this is O of 1 operation. Okay. But now we need to update the positions, right? So what we can do is just mark that now we just need to change, because now when we do this here, now we have like this. We just need to change this index to this map to be here 2 pointing to 1, and delete this, or mark it as deleted or something. So for the first portion, which is setting for 2 the index to be 1, we will just say for self.values at position I, which is what the 2 is at now, and we want to mark it as this position, and that position is basically I, right? Okay, so once we do that, we can just delete self.positions for this this 2 here, the last one, right? Or we can do it differently, right? So we just say 2 to 1 actually. So we say 2 to 1 here, and then delete this one. That would be easier. And so we'll delete for val, which is the 5, right? So it deletes 5 pointing to 1. Okay. Except this deletion here may be O of n, and I would like to avoid it. Even if it's not O of n, it's just not great. So we just want to avoid it here. So how can we avoid it? Well, it should be pretty simple. The indexes of the arrays are positive, right? So we can just put -5 here, 0.5 to -1, right? And also, like in other languages, it doesn't even exist. So instead of doing this, we want to just fill it with -1. So what we want to do is do here -1. Okay. And in this case, we can just check if val is for remove. We can just check if val is in remove, is not in the positions, or its value is equal to 1. In both cases, that means it's removed, right? So that's exactly what we'll do here. So value not in. Here we now check positions, so that it's O of 1 operations, because checking an element is in the map is an O of 1 operation. And we want to check that the positions for val is different than -1, right? Okay, equal to -1. So this is OR. Okay, so val not in self.position, or so the value not in positions, or it was removed before, so it's equal to -1. So that's where we want to remove it. And here, the value is in this, and it needs to not be removed. So we need it to be different than -1. Okay. And now here, we just need to update it to make sure we add the position for val, because we added it to the end of the list. It's just the length of self.values -1. Okay. And here, we want to remove this. We want to get rid of this because it's O(n), and we'll do exactly what we said here. Just clean it up a little bit. So it would be like this. So we get the index first of the value. We replace it by the last one, and we pop the last one because pop is O(1). And then we insert in position the new index for the last value. Okay, and then here we just set it to -1 to mark it as removed. And that should be it. There is only one little thing that we need to do here. I'll just first mark this like this. But here we just need to make sure that for this to work, I needs to be smaller than than the length of the list after we remove the last element, just in case there was one element. So the length, so just for index, to not get index out of bounds. Okay, and we can now remove this. And now it's O(1) operations because this is O(1), this pop is from the end is O(1), this assignment is O(1), and this assignment is O(1), and here also everything is O(1). And here it was already O(1), right? So all of the operations are O(1) now, and we can submit. And this passes. Now, one simple modification we can make that works only in Python actually, because Python allows us to have a default value for absent values from a map with just lambda, so we can default to -1. That way, the only check we will need to do is that the value is equal to -1. This means that it's not present. And same thing here. We don't need to do 2 checks. And we can submit. Okay, so that works now. Yeah, so pretty much that, O(1) for every operation, and for the entire thing we are using 2 extra lists here, so it would be O(n) and being the number of inserts. Yeah, so yeah, that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.